So traffic safety is a major, major issue in Canada. Tragically, more than 1,700 people lose their lives on our roadways every single year. This is a tragedy that we need to address, and in fact, cities across the country have Vision Zero initiatives. If you're not familiar with Vision Zero, it is to bring that number down to zero in terms of injuries and deaths on our roadways. We've been working on a solution to help with this. Sometimes making decisions about how to improve traffic safety is not as simple as it seems, and we have created a solution along with our partners Synexus to create a next generation modeling and simulation solution, not only in 2D, not only in 3D, but also in virtual reality. I'm going to show you what I mean. So here we have, imagine yourself immersed in this virtual reality scenario. Instead of just looking at a report about how to make a decision to improve safety, you can actually immerse yourself in the scene itself. You can see here from the city of Montreal, we can choose various different roadways, and we can choose different modes of transportation to put ourselves in. Here's an example if you're in a vehicle. We are using real data from the city of Montreal in this case in terms of what is the congestion level, what is the volume of traffic of different modes on the roadways, what does the scenery look like. So it really is immersive and true to life. You are then able to put yourself in this scenario. So really this is about making an emotional connection to the way that the roadway actually feels, in this case when you're driving in a vehicle. While you're going down this scene, you can kind of go beyond just modeling and simulation, but into education, into better decision making in order to improve the safety of the roadways. So driving in a car is one thing, and we can then choose different modes. This prototype that we built, which was in conjunction with the City of Montreal, also supported by the City of Toronto and Halifax Regional Municipality and ITS Canada, you can then choose, for example, being on a bicycle, right? So being on a bicycle, if you're like me and you do a lot of cycling in the city, if you're doing this in this scenario with no dedicated bike lane, I think you know how that feels. But if you've never ridden a bicycle in this scenario, this solution in VR is an excellent way to actually connect with the level of safety in real life. What if we did have a bicycle lane? So this is where we can model and simulate different scenarios in real time. This is extremely fast, obviously much faster than truly building out the bike lane to see what that would be like. And here immediately as a cyclist, I get a much, much safer experience. So I'm riding down the bike lane and I no longer feel threatened by the vehicles driving by me. If you'd like to try this solution yourself, visit our transportation kiosk in the exhibition hall after the plenary. The second solution I wanted to show you is about traffic congestion. So I think those of you who drive around any street in any of our major cities are aware that traffic congestion is a major, major issue, not only for productivity and the economy, but for our mental health as well. The most exacerbating factor, as you can see here in the media, is construction. We have to do construction. We're building our cities. That is a necessity. And this is largely to blame. This is a major cause of lane closures. The City of Toronto has recently implemented a new digital process in order to have contractors log and request permission to close a lane. This is called Rodars. It was implemented with our Esri business partner Transnobis, who are here with us today. This is an excellent process. It gets everything in terms of permits for lane closures into a digital system. You can see here that we have actually mapped all of the lane closures and actually correlated that with what number of bus routes are impacted, what number of cycling routes are impacted by all of these lane closures. So that is one level of detail. You can also see all of the kind of congestion levels correlated with those lane closures. However, the next question we asked ourselves was, what if there are lane closures that do not have a permit? What about those? So we created a solution with our Esri business partner Raven Connected. They make this device, which is an onboard unit on a vehicle. So it sits on your dashboard, and on the front here is a road-facing camera. The beauty of this solution is that these are already deployed in every major city in Canada, so we have data flowing in from all of these already. what we did was we took the data from the Raven unit and we correlated that with the city's permit database, in this case, City of Toronto roadars. And here's what we found. So you can see on this map, all of the orange icons are the permitted lane closures. And then if we zoom in a little bit more, you'll see there are red and green polygons. The red polygons are where there is no permit. Let me show you an example. Let's start with one where there is a permit. So if we go to Queen's Park, if any of you are driving around Toronto, you're probably familiar with this. Let's see what the Raven saw. You can see this picture. I'll blow it up for you a little bit. Oh, fair enough. Construction, lane closures, but there is a permit, so that's all good. We'd like this to be cleared as soon as possible, but no issue there. Let's look at a different example. If I go to another example, let's say a little bit north on Oriole Parkway, you'll see that in this example, we have a red polygon, and this means there is no road closure permit here. What do we have? As we can see from the Raven imagery, there's a construction vehicle parked in a live lane. Maybe there was a permit before, maybe it just hasn't been moved out of the way. Either way, this shouldn't be here. This is a great solution to help any city prioritize their enforcement of reopening lanes that should be open in the first place, and one of many ways that we can start to improve roadway congestion and get the traffic flowing. With that, I want to pass it over to Matt, who's going to show us an example of this in a 3D digital twin.
All right. Thanks, Dan. So we're going to get this up on the screen. You're looking at a digital twin application for Toronto. And the first thing we want to point out here is a brand new offering. We've partnered with Google to produce a Google photorealistic 3D basemap. And if you're taking notes, this basemap is going to be available in ArcGIS Pro at 3.6, the next release of ArcGIS Pro. If you're a pro user and you're connected to ArcGIS Online, you're going to get this basemap. And you can see that it really starts to bring your GIS to life. It breathes life into a 3D environment. Worldwide coverage, high fidelity detail in many of the urban areas. We're going to turn on some sensor information here. Our bike share stations, right? These bike share stations, let's click on one of these right here. So it's using smart mapping, right? Red color all the way to green. Green means lots of availability at a particular bike share station. Here are 0 e-bikes available, but 44 classic e-bikes. So smart mapping works really nicely with this new Google photorealistic 3D basemap. Let's do this, and I'll turn those off. Let's look at some of the sensor information that Dan was just talking about in his 2D demonstration. So, road closures. There are lots of road closures and permitted work going on in the city, as we saw in Dan's demonstration. We'll click on one just to kind of get a look at what's going on in a particular area. The next thing we want to do is connect to that Raven system that Dan was just showing. So to do that, I'm going to turn this Raven layer on, and we're going to zoom right down to Avenue Road and Bloor Street, the Royal Ontario Museum. And our friends at Raven, in addition to producing this wonderful data set from these dashboard cameras, have also published that data as an oriented imagery layer. So if you're taking notes, that's another thing that you can do with ArcGIS, is publish the camera information with the data. So if we zoom in here, this is the Royal Ontario Museum. I'm going to click on one of these view sheds, and we get an oriented imagery viewer, which will let us look in 3D. So if I zoom in on the right, watch the left-hand side, and we'll do this, and we'll kind of look around inside the photo on the right and be able to see what's going on in the 3D scene view on the left. So this is an oriented imagery layer and a viewer that just works in the scene viewer. And with that, I'm going to turn it back to Alex.
Thank you, Matt. Oh, thank you, Matt and Daniel.